Hello everybody! We are back with the applications with derivatives. Now first things first, this is tangents to graphs of functions. Now if we're looking at tangents, right, to certain functions, we are talking about the straight line equation. Okay, so the straight line equation, which I'll just give you, so the tangent equation, I'm going to write down here, tangent equation, so I'm going to say like so, the tangent EQ is going to be y is equal to mx plus c. Now notice that the m, remember the m resembles the first derivative of the function according to our first principles that we've dealt with already, and the c represents just the y-intercept, right, of that straight line function, of that tangent. So therefore we can actually write this equation in the form of y is equal to f prime of x times x plus c. Okay, meaning we need to find the first derivative of the function at a certain point. By the way, this point needs to be at a certain x value, and then obviously c would just be the intercept that we will find at the end. So let's go into the first example and see how this is actually applied. Okay, so here's the first example. Determine the equation of the tangent to f of x equals x squared plus 4x plus 3 at the point where x is equal to 2. So when x is equal to 2, we need to know what is the coordinate at that point for the following. Y equals 2, I'm going to write here f prime of x times x plus c. Okay, where obviously f prime of x is just the gradient. So therefore what we need to do is the following. We need to know what is the y value that we are working with. We know the x value is 2, but how are we going to find the y value of the function at x equals 2? Well, clearly we need to let x be equal to 2 for the function in order to get the y value, the output. So our input would be 2 and our output would be whatever value we get out of f of 2. So first things first, f of 2, so at x equals 2, we have f of 2 which is equal to 2 squared plus 4 into 2 plus 3. And what is this equal to? This is just going to be 4 plus 8, which is equal to 12. 12 plus 3 is equal to 15. So this implies to us that at x equals 2, our coordinate would be 2 and 15. Because this is our y value, our output. So there we go. We just found our x and y values. But now remember, since we found our x and our y values, we need to find our f prime of x. And how do we do that? We need to look at the function of x, which is x squared plus 4x plus 5, right? Or sorry, plus 3. And we need to take the derivative on both sides in order to get the first derivative. So therefore, all we need to do is we need to take d by dx of f of x on both sides. So d by dx of x squared plus 4x plus 3. And since we are so familiar with derivatives, okay, the derivative of f of x is just f prime of x. This implies to us here that the derivative we can just take into each and every single term. So we don't have to keep writing it out, but it's good practice when we distribute the d by dx. The derivative of x squared is just going to be 2 times x to the power of 1, because it's 2, well, I guess I'll say 2 minus 1, okay? Plus the derivative of 4x is going to be 4 multiplied by x to the power of, so 4 multiplied by 1 times x to the power of 1 minus 1, plus the derivative of a constant is just 0. So therefore we're going to have 2x to the power of 1, which is just 2x, and plus 4 times x to the 0, which is just 1, so it's 4. So f prime of x is equal to 2x plus 4. But remember, we're saying it's at the point what? X is equal to 2. We are working with the point x equals 2. So we are going to say that the gradient at the point x equals to 2 is just going to be 2 into 2 plus 4, which is just equal to 8. I'm going to write down over here what this is. This represents the gradient at x equals to 2. That is our notation. And do you notice what we just found? We found the gradient at the point of the tangent. So now we can substitute that in. Okay, so I should have actually said that this x value is supposed to be 2. Okay. So therefore, what we are going to say is that we have the equation y is equal to f prime of 2, right? Because that is our point, right? Multiplied by x plus c. And what do we know? We know what y is equal to. We know it's 15. We know x is equal to 2. And we know that the gradient is 8. So all we need to do is find the constant. And that implies to us that we are going to have 15 equals to 8 multiplied by 5 plus, not 5, 2 plus c. Okay. And then this implies to us, if we take everything over, we're going to get c is equal to, what is 8 times 2? 8 times 2 is 16, so we have negative 1. So therefore, since we know that this is the standard form, we need to write down in the form of y equals mx plus c. So therefore, the equation is y is equal to m, which is 8, or f prime of 2, which is 8 times x minus 1, because we found our c value. And that is how you find the equation of the tangent. Let's see if we can do another example. Alright, so we need to find the equation of the tangent to xy equals 8 at x equals 4. Now this one looks funny, but remember, we always need to find it in the form of y equals to something. So xy equals 8 is actually going to be represented as y equals 2. If we divide both sides by x, we have 8 over x. So this is actually a hyperbola. So now we know that the point that we're working with is at x equals 4, but we need to know what is the y value. What is the y coordinate? So we're going to say here, at x equals to 4, we are going to have y is equal to 8 over 4, right? Which is just equal to 2. So this implies to us that the coordinate that we're going to work with is going to be 4 and 2. Alright. 4 and 2. Now what we need to find is the gradient, okay? And remember, the straight line equation that we're trying to find, which is the tangent equation, is going to be in the form of y equals mx plus c, but we need to find out that what m is, and m is just the first derivative of the function, which is going to be what? dy by dx, because remember, it's in the form of y equals, so we'll be working with dy by dx. So if we look at y equals to 8 over x, right? If we take the derivative on both sides, so d by dx of y equals to d by dx of 8 over x, then what this implies to us is that the derivative of y with respect to x is just going to be equal to dy by dx, which is equal to the derivative of this. Okay, remember what I said in the other video, or I'm going to show you now, is we can only use the power rule when we have an exponent and we don't have a variable in the denominator. So we can rewrite 8 over x as 8 times x to the power of negative 1 in negative exponent form using exponent rules. So dy by dx is just going to be equal to what? Well, we can take the 8 as a coefficient out using the rule of differentiation, and then we can be left with negative 1 times x to the negative 1 minus 1, okay, the power rule. And therefore we are left with negative 8 times x to the power of negative 2 dy by dx. And we know we can write this as dy by dx, okay, is equal to negative 8 over x squared in positive exponent form. And what is happening now? We need to find the gradient at the point x equals to 4, right? Because that was the question. It says find the equation of the tangent at x equals 4, and then we're just going to plug it in. So what is the notation that we use? We can literally just say at x equals to 4, then we say dy by dx equals to negative 8 over 4 squared. And we know that it's just going to be negative 8 over 4 squared, which is 16, so therefore it's going to be negative a half. Okay, so what does that imply to us? This is just the gradient at x equals to 4. So what does that imply to us? We can see that it's actually in the form of y equals to dy by dx times x plus c, which is, this is the gradient. And we know that y is equal to, what did we find y to be equal to? It was 2, right? So y is equal to 2, and we know x is equal to 4, and we know that the gradient at the point x equals 4 is just negative 1 over 2. And now we just need to solve for c. So therefore, if we want to solve for c, we're just going to do the following. We're going to have 2 is equal to negative a half times 4 plus c. And then we're going to put c on its own. So c is equal to, we can take the, we can actually simplify this. This is going to be 4 divided by 2, which is just going to be 2 over 1. So it's negative 2 comes over as a positive 2, so c is equal to 4. Okay, so therefore, the equation is just going to be y is equal to, what was our gradient? It was negative a half multiplied by x plus 4, because this is a positive 4. So there is the equation of our tangent. It is really not that bad for these types of questions. Let's go to the next example. Alright, so this one looks a little bit scary, but it's actually not bad. Given f of x equals x squared minus 2x, we need to find the equation of the tangent to f, which is parallel to the line x plus y equals 7. Oh my goodness, what are we going to do here? Scary, hey? What I want you to know is that we have the tangent of this equation parallel to the line x plus y equals 7. So if I rewrite x plus y equals 7 into the form of y equals mx plus c, we will have y is equal to negative x plus 7, right? Because you just take the x over and it becomes negative x and then plus 7. Do you notice that this implies to us that our gradient is equal to negative 1? Okay. Which further implies that our first derivative at the point is also going to be negative 1. Our gradient at the point, which is also the first derivative, is equal to negative 1. Okay, but think about this. Why am I saying f prime of x instead of some other function which, because it's a new line, could be a different function? Well, think about it. If two lines are parallel, what are we saying? If this line here, if we have a line like this, what would the other line be if it was parallel? Wouldn't it just look something like this? And then what you would notice is both of them are parallel to each other. But the gradient of this, right? The gradient of the function here, let's say it's equal to a. This would also be the gradient of a. Why? Because the slope is exactly the same. The slope is essentially just the gradient. So what that means is that the gradient of this line is the same as the gradient of the function here, if they're parallel to each other, because the key word is parallel. So if we found the gradient of the line that they gave us, which was x plus y equals 7, therefore we found the gradient of this tangent, the tangent of this function f. So therefore, what we are saying is that when we want to get it in the form of y equals to mx plus c, we'll say f prime of x, so at the point obviously, x plus c. So all we need to do is we need to find out what is the y value, what is the gradient at that point, and what is the x value. But my question to you is, do we know what the x value is? Well, how do we find that? Well, the way we can do it is from the information we have. F prime of x is equal to -1. That is what we're going to be using. F prime of x equals -1. But my question is, how do we get to f prime of x? We only just take the derivative of f of x. So we are just going to say here, using this information, we are going to say that f of x, we know it was given to us as what? F of x is equal to x squared minus 2x, right? Okay. And to find the derivative, we take the derivative on both sides. And notice that from here, okay, the derivative of f of x is just f prime of x. And this is just equal to what? This is equal to the derivative of x squared, which is just going to be 2 times x to the power of 2 minus 1, minus 2 times x to the power of 1 minus 1. Okay, when we take the derivative of both. And then, what do we remember? Remember that f prime of x is equal to -1. So we just substitute f prime of x here. Okay, so this implies to us here now that we have -1 is equal to 2x to the power of 1, which is just 2x, minus 2 times x to the 0, which is just 2. Okay, and then we just solve for x. So we have 2x is equal to, that'll be -2 goes over, so it'll be 2 minus 1, which is just 1. And then therefore, x is just equal to 1/2. So guess what we just found? We just found x. And we already knew what f prime of x is. All we need to find is just y, and then we can solve for c. So to find y, we just plug x into the original function. So now we're going to say that f of 1/2 is just going to be equal to what? 1/2 squared minus 2 into 1/2, which is just equal to what? 1/4 minus 1. And 1/4 minus 1 is just going to be the same as 1 minus 4/4. If you do the simplification in your head, it'll just be -3/4. Okay, so this implies to us that our coordinate will just be it'll be 1/2 and -3/4. So xy coordinate will be 1/2 and -3/4. So therefore, this just implies to us that for our y equals to mx plus c, where m is just going to be the first derivative at the point, this implies to us that y is equal to -3/4, which is equal to what? What is m equal to? M was found to be equal to -1 times x, which is 1/2, plus c, and we just solve for c, right? -3/4 is equal to -1 times 1/2, which is just -1/2, plus c, and then we just put c on its own, take -1/2 over as +1/2, and then what are we going to get? If we do that in our heads, we're going to get -3/4 plus 1/2, but we want the denominators to be the same, so we multiply the top and the bottom by 2. So then what we're going to have is -3 plus 2/4, which is just going to be equal to -1/4. So therefore, c is equal to -1/4, and therefore the equation of the tangent that we have for f is just going to be y equals to -x minus 1/4. Remember, the -1 is our gradient, so we already knew that. Okay, and then minus 1/4 is our c value. Okay, all right. So here's your question. I want you to try by yourself, and this one's going to be a little bit interesting, but it's not that bad. Show that f of x equals x squared and g of x equals negative x squared plus a half intersect at 90 degrees. And I gave you a hint to say that perpendicular lines imply to us that m sub 1 times m sub 2 is equal to negative 1. Remember that there's two different gradients because they're intersecting at 90-degree angle. That is the only hint I'm giving you. I want you to see if you can intuitively answer this question based off of the information you've just received. All the best.